Welcome back to part 4 of transverse waves. In today's lesson, we're going to discuss how to calculate the speed of transverse waves.
Okay, so let's look at the two formulas that we can use to calculate the speed of a transverse wave. So there's two formulas that we can use. The first one is the wave speed, or the speed of the wave, which is always measured in meters per second, is equal to the frequency times the wavelength. So frequency, once again, always measured in hertz, while wavelength is always measured in meters. Please pay special attention to your conversions. If the value is given in millimeters or centimeters, make sure that you convert the value back to meters if we are talking about wavelength. Now the second formula that we can use is V is equal to the change in distance over the change in time. Change in distance is once again always measured in meters. If they give it to you in centimeters or millimeters, remember to convert back to meters. And then our time is always measured in seconds. So let's look at a few examples on how they can ask these type of questions.
Okay, let's quickly look at some examples on how to calculate the speed of the wave. So for the first example, they have given us the transverse wave and now they ask us calculate the speed of the wave. So what do we need to calculate? We need to calculate speed. Highlight for yourself what you have to calculate so that you don't get confused. So let's quickly see what information do we have on this transverse wave. So then all the information that you have, make sure you write it down for yourselves so that you can see what information I have and what information do I need. So let's quickly write down what I have. So we can see here that we have the wavelength, because the wavelength stretches between 2 points that are in phase, and here they have given us the distance. So from the start to the end for this wave, the wavelength is 0.6 meters. What else did they give us? We can see that they've given us the period, because period is how long it takes to complete one wave. So the period, capital T, is equal to 0.4 seconds. What else? They have given me the total distance that this wave traveled. So they have given me delta x, which is 1.8 meters. What else? They also gave me the time that it took to complete this entire wave. It took me 1.2 seconds, so delta T is equal to 1.2 seconds. What else? Okay, now let's go to our question. Calculate the speed of the wave. We all know by now that the symbol for speed is V. So there's only two formulas that we can use to calculate the speed of the wave. So the first one is we can use V is equal to frequency times the wavelength, or we can use V is equal to the change in distance over the change in time. So let's say we're first going to use the formula of V equals FA, because I do have enough information. Even though they haven't given me the frequency, can I calculate the frequency? Yes, I can, because frequency, we all know by now that frequency can be calculated by 1 over T. And do I have T? Yes, I do have T, which is 0.4 seconds. So then I'm just going to substitute 1 over 0.4. Then you grab your calculator. So 1 over 0.4 gives us an answer of 2.5 hertz, because remember, frequency is always measured in hertz. So obviously now I have the frequency. Do I have the wavelength? Yes, I do. They've given it as 0.6 meters. So can I use the first equation? Yes, I can. So let's do our calculation. So V is equal to frequency times wavelength. Then I'm just simply going to substitute 2.5. Always remember to put your substitutions in brackets. So 2.5 times the wavelength, which is 0.6, and then I'm going to grab my calculator once again. 2.5 times by 0.6 gives me an answer of 1.5. And what is my unit for speed? It's meters per second. So there you have it, there's your answer. But this is not the only formula that you can use. For the people that used the second formula, it's also correct. So let's quickly see what will be the answer if we used formula 2. Do we have enough information? Yes, we do. We have delta x, which is 1,8. We have delta t, which is 1,2. So v is equal to change in distance over the change in time, which is going to be 1,8. We don't have to convert because distance is already in meters. If it was millimeters, then we need to convert to meters. So 1,8, and then the time was 1,2. Then I'm going to put it in the calculator. So once again, 1.8 divided by 1.2 going to give me an answer of 1,5 meters per second. Can you see that we get the exact same answer? So it doesn't matter which equation you used, it will always be correct. Always make sure that you write down what information you have and what information you need, and then you check where you can substitute or what else can you calculate. In my opinion, I would have used this formula because this is just a way shorter, or this is just a shorter version to get to your answer. For instance, in the first one, it will still be correct, but first you will have to calculate frequency, and then you have to go back to your formula. So in my opinion, I would have used this one because it's just a way shorter way to calculate the speed. So let's quickly look at example 2. Okay, so for these type of questions, once again, grab your highlighters. So let's highlight what do we have. So they ask us, calculate the speed of the wave if the wavelength is 3 meters. So we need to calculate the speed of the wave with the wavelength being 3 meters and the period of the wave being 0.1 seconds. So once again, what's the first step that you need to do? You write down what you have and what you need. So what do we need to calculate? We need to calculate V. V is what we want. What other information do we have? We have the wavelength, which is 3 meters. We do not have to convert because wavelength is already in meters. If it was millimeters, then we had to convert. Then what else did they give us? They gave us the period, which is 0.1 second. Okay, then obviously we know there's only 2 formulas that we can use to calculate the speed of the wave. So the first one is we can use V is equal to frequency times wavelength, or we can use V is equal to the change in distance over the change in time. So let's see, what information do we have? We have no information about the distance. We have no information about the time. So we cannot use this one. So this one is a no. We must use this one. So let's quickly see. We need to calculate V. We have wavelength. But what do we still need? We need frequency. How can we calculate the frequency? We know that there's only one formula to calculate the frequency. So frequency is equal to 1 over period, which is 1 over 0.1. You grab your calculator. 1 divided by 0.1, you get an answer of 10. 10, what is the units for frequency? It's always hertz. Remember your units. Now we do have frequency, so then we can jump into this equation to calculate our speed. So then we go to V is equal to frequency times wavelength, which is going to be this 10. Remember your brackets. 10 times the wavelength, which is 3 meters. I do the calculation and you will get 30 meter per second. And there you have it. There's your answer. Let's quickly look at the third example. Okay, Okay, so let's look at example 3. Grab your highlighter so that we can highlight what they are asking us. Calculate the frequency, so we need to calculate the frequency of a transverse wave with a speed of 8 meters per second and a wavelength of 200 millimeters. So then our very first step that we need to do next is we write down what we have and what we need to calculate. So we need to calculate the frequency. But what do we have? We have the speed of the wave as 8 meters per second, and we have the wavelength of 200 millimeters. But what is wrong here with the wavelength? We know that wavelength needs to be in meters, but the value given is in millimeters. So how do we get from millimeters to meters? Let's go to our conversion cloud. So we are at millimeters, but we need to get to meters. So what path are we going to follow? We are going to jump to orange places. So from millimeters to meters, we jump 1, 2. But while we are jumping, what are we taking with us? We take with a 10 times 10 to the power of negative 1 and a times 10 to the power of negative 2. So if we take these two with us, we get times by 10 to the power of negative 3. And there you have it. To get from millimeters to meters, you take your value given times 10 to the power of negative 3. So our new converted value is 200 times by 10 to the power of negative 3. Remember your brackets, meter. So let's go to our calculation. So we know by now that there is obviously a second formula on how to calculate frequency as well. But what is the first one that we know of? Frequency is equal to 1 over period. The second one is speed is equal to frequency times wavelength. So what information do I have? Do I have any information about the period? No, I don't. So immediately you know this formula is a no-no, then I must use this one. So speed is equal to frequency times the wavelength. My speed is given as 8 meters per second, so I substitute in there. Frequency is what we want, and then wavelength is given as 200 times 10 to the power of negative 3. Now I need to get frequency alone, but how do I get frequency alone? I need to divide the wavelength away. So what I do on the right side, I must do on the left side. So once I'm dividing this one away, 200 times 10 to the power of negative 3, I must divide on the left side as well, which is 200 times 10 to the power of negative 3. And then these two are going to cancel each other out. So I'm going to be left with frequency on the right side, but what's then left on the left side? You grab your calculator. Let's quickly do our calculations. You have 8 divided by 200 times 10 to the power of negative 3. Remember to close your bracket again, and then you get an answer of 40 Hertz. Remember your units. If you forget your units, you're going to lose the entire mark for your answer. And that's it. Thank you for watching. Stay tuned for the next videos.